Hi there, and welcome to my channel. In this question, we are given the differential equation dy over dx equals 1/2 sine pi over 2x times square root of y plus 7. So this is implicit function for the differential equation. And then we are given that y equals f of x is a particular solution to this differential equation with the initial condition f of 1 equals 2. And this function f is defined for all real numbers. And the first question is, we are given a portion of a slope field here in this chart for the differential equation. And then we need to sketch the solution curve through the point 1, 2, and the point is given here for us. And so how do we sketch that solution? We start with the point 1, 2, and then we go along the slope field so that the line is tangent to the slope field. And so this is how it's here. You can see that it's tangent all the time, and then moving in this direction, it's tangent here, here, here. And so it looks like almost like the sine or a cosine function. So this is the answer to this question. Let's move on to question B. Here we need to write an equation for the line tangent to the solution curve in this part A at the point 1 and 2, and use that equation to approximate f of 0.8. So let's find the slope of this tangent line, and the slope is, as usual, is just dy over dx, evaluated at the point 1 and 2. So we plug in x equals 1 and y equals 2 into the equation for the derivative. So this is equal to 1/2 times sine pi over 2 times 1 times the square root of 2 plus 7. And this is equal to 1/2 times sine of pi over 2 is 1 times the square root of 9, which is 3. So this is equal to 3 over 2. So the slope is equal to 3 over 2. And the point, so how do we find this line? This line has to go through the point x0, y0, which is the point 1 and 2. And it has to have a slope equal to 3 over 2. So what is the equation of this line? The equation of this line is y minus y0 equal to slope, just a reminder, x minus x0. Plugging in our values here gives us y minus 2 equals 3 over 2 x minus 1. Adding 2 to both sides gives us y equals 2 plus 3 over 2 x minus 1. And so we found the equation of the line, and then we need to approximate f of 0.8. And f of 0.8 is, we just plug in 0.8 for x into the equation of the line. This is approximately equal to 2 plus 3 over 2, 0.8 minus 1, which is equal to 2 minus 2 plus 3 over 2 times negative 0.2, which is equal to 1.7. So the approximation of f at 0.8 is equal to 1.7. Let's move on to part C. In this part of the question, we are given that the second derivative is positive for the interval from -1 to 1. And then we need to answer whether the approximation that we just found in part B is overestimate for an underestimate for the true value of f at 0.8. And so given that the second derivative is positive, we know that this function is concave up. And so let's do a little graph here, which will allow us to see where whether it's over or underestimation. So because it's concave up, the first derivative is increasing. And let's say this is point x equal 1. And then we can see that the tangent line is actually lies underneath the curve. This is f of x. And this is tangent line that we just found. And so the value of x equals 0.8 is somewhere here. And then the value that we gave for the estimation is here. So this is the value that we found, which was this point, is underestimate. And if we don't remember that for the second derivative to be positive, it gives us underestimate, then a little graph like this will help us to see that. So just when you don't remember something, try to make a graph and see where that leads you in terms of the answer. In this question, we are being asked to use separation of variables to find y equals f of x, the particular solution to this differential equation with the initial conditions that we already had, f of 1 equals 2. And so let's use that separation of variables technique. dy over dx is equal to 1/2 sine of pi over 2x square root of y plus 7. And how we do the separation of variables, we bring y to one side and x to the other side. And so divide by square root of y plus 7 and multiply by dx. We get dy over the square root of y plus 7 equals 1/2 sine pi over 2x dx. Integrating both sides gives us integrate this expression equals the integral of the right-hand side expression, gives us integral from the left-hand side. We can do the u substitution y plus 7 and see then the integral will be equal to 2 square root of y plus 7. So if you differentiate 2 times square root 1 plus 7, you will see that it will give you 1 over square root of y plus 7. This is equal to, and the integral from the right-hand side will be negative 1/2 times the derivative, the integral from sine pi over 2 will be 2 over pi times cosine pi over 2x plus some constant. They are equal up to a constant. And so then in that case, we need to plug in the initial condition f of 1 equals to here. Plugging it in gives us 2 times the square root of 2 plus 7 equals negative 1/2 times 2 over pi times cosine pi over 2 times 1 plus a constant. And so this term is 0 because cosine pi over 2 is 0. This term is 6. And so we see that c is equal to 6. So then our equation becomes 2 square root of y plus 7 equals negative 1 over pi cosine pi over 2x plus 6. And so we need to solve for y to find this solution. Let's solve for y. Divide by 2 and square both sides gives us y plus 7 equals negative y over 2 pi cosine pi over 2x plus 3 because we divided by 2 squared. And so finally, we just need to subtract 7 gives us y equals negative 1 over 2 pi cosine pi over 2x plus 3 squared minus 7. So this is particular solution to that differential equation. Thank you for watching. If you liked this video, please don't forget to click the like button, write me your comment below, and subscribe to my channel where you can find more solutions to the AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.